Okay, so we are live. Hello, everyone, and welcome to the day three of Cloud Native Sustainability Week. And my name is Sayam Padak, and I'm a CNCF ambassador working as a field CTO at CVO. And I'm joined by Divya.
Hi everyone, I am Divya Mohan and I'm also a CNCF ambassador. No surprises there, to be honest, because this is the Cloud Native Sustainability Week. You know, driven by the tag environment sustainability under the CNCF. It should not come as a surprise. but yeah, I work as a senior technical evangelist at SUSA. And over and above all the open source cloud native work that I do as part of my day job and as part of my ambassadorial, I hope I got the adjective right, duties. I am also one of the maintainers for documentation on the Kubernetes project. So that's a bit about me and Sayam. But if you haven't sort of been in the know and you are joining us brand new today, Sam, do you wanna tell people why we're all here today and what's exactly gonna happen next?
Yep, definitely. So, setting the context again, as always, we do. So, the Cloud Native Sustainability Week comes under the tag Environment Sustainability, which falls under CNCF. And this week, we are committed to do the series of live streams. There are actually a lot of events happening globally, in person, virtual, and this is one of the part that we are playing in this particular sustainability week. The whole point is to bring and raise awareness, not only just about the terminology of yeah, sustainability is important, yeah, we should be thinking, but from the tech side of things, from the software side of things, from the hardware side of things, learning about some of the stuffs. For example, day one that we had with Hendrik, we learned a lot about Cube Green project that scales your deployment down to zero, Kepler project that gives you the metrics and via probed via eBPF, and then goes to the machine learning model and getting you the exact carbon footprint for your workloads in specific namespace, and how these two can actually work in conjunction to create a meaningful workflow. And Divya has already written a small blog on that as well. On day two, we learned about the hardware side of things. Like we all know that the data centers, the number of data centers are going up, and it's obvious, right? Everybody wants to create more and more stuff, especially with the open AI stuff coming in. People are like crazily developing open AI apps and building new apps, simplifying problems and creating a new tooling, and they need somewhere to deploy their workload. And for that workload to cater those, they need, like, the cloud providers or local vendors, they need to deploy the data centers. So the need for having the data centers will keep on rising, but there is a limit to the electricity consumption that can be happening. So we need some sustainable solution for making sure that the whole workflow, the supply and demand for the data center, everything works. And nothing will work if it just sit like this. We have to open our eyes, we have to open our ears, we have to open our brains to think and understand what is happening in this ecosystem. How are people innovating? And that's where Mark from Deep Green, who is the Deep Green CEO, he came in yesterday and talked about some of the challenges with data centers and some of the cool solutions that they are working on. So they are using the edge location data centers, like placing that close or near or in the swimming pool area, and then using the heat generated by that data center to heat up the swimming pools. So that is one use case, and that also solves a problem, like that is reusing the heat generated by the data centers, plus solving a very critical use case of heating the swimming pools. And there are like n number of swimming pools in the EU, Europe, and UK area itself. So that is happening. And then moving on from there, definitely the vision. So vision is pretty important. So there are like 30% which I remember from the slides, 30% of more areas where these can be applied, like more ways in our day-to-day life where we can reuse the data center heats and place the edge data centers closer to those locations, and then make sure we can reuse the heat and make things more sustainable. And then there are energy things, there are like windmills that we talked about, another dimension of water, which is a whole new thing. And then how things are going to fall, like everybody, this thing will become so like not common, but it will be absolute that everybody is using the same thing, and innovating on top of it. Like it'll not be rocket science that oh, you have to do something special. Like people, when buying the stuff, buying the hardware, they will have the this sort of plan how they are going to implement it. So I think um, that was pretty insightful. And we, as like at Sivo, we are partners with Deep Green, so that sort of relationship is already there. So what that means is, when there is a Deep Green region within Sivo, so let's say you log into Sivo and you try to create a compute, or you try to run a GPU workload that is actually powered by Deep Green, 100% renewable infrastructure that is heating up a swimming pool. Now, how cool is that? You can do it. So that's the efforts. I think that's where the hardware software combination can be really really powerful, really create a powerful use case, powerful story, powerful sustainable angle. So that's what we learned yesterday. Today, although we were supposed to have Dheeraj, but due to some issues, we are not able to get Dheeraj. But it's not the end case. So we have Raj, who is the founder and CEO of Avesha, has joined us, and we will be discussing about the sustainability, like what sustainability means to them, and a solution that they have built that helps in this area, or envisions this area more, which is the smart scaler. So we'll be discussing that. Thank you so much, Raj, for coming in and filling in Dheeraj's spot. I know always a pressure situation to to be last minute to do this thing, but it's okay. We are chill, we are cool over here. So anything you would like to share is obviously recorded, but it's okay, it's cool. Um, and
Yeah,
yeah, if you can just introduce yourself to the audience first.
absolutely. Absolutely. Thank you, Sam and Divya, so for giving us this opportunity to share what we have done in the space. And it is very close to my heart. I've been very interested in coming up with a solution that is a very big problem that we see, which goes really down to the heart of the matter, which is looking at applications, looking at what practically happens in a in a in a SRE team, in a DevOps team, where first of all, you know these guys have a very stressful job anyway, and then on top of that, there are demands from obviously from their customers and from their stakeholders saying that they need the best performance, and they have to, and at the same time, they they have a very limited time to operate in. So they, especially situations where the loads are very unpredictable and spiky, they just have to do something quickly. They still don't know whether it'll work, and so it's a very stressful situation. So you end up with this case that most of the time it's all over provisioned, and so an application might only need a certain number of parts. Let's say it needs say 3 parts, but they give it 10 parts because they just don't want to be woken up at night, and I can understand that situation. um, so we said, how do we solve this problem, with in a data-driven way? So we look at data, we look at its performance history and all, and then we literally have a digital twin, of of each microservice, in fact, and then that is used in this model that we use. In fact, we use a reinforcement learning model, and then pretty much like what the generative AI is using, for ChatGPT, it's the exact same model actually. The proximal policy optimization, and then with that, we are able to essentially give you a very controlled and measured way of scaling up and down pods. But the beauty of it is it's completely automatic. So you can save on your footprint a lot. You don't need to go and overestimate, and at the same time, even if it's not necessarily a situation where say some pattern you have, and or some known events, you can actually have an event-based scaling also, which is part of this. So, but then it self-corrects. So that's the beauty of it. So this way, you have the ability of dealing with idled servers, which is really the most egregious, right? Like we have servers sitting around there doing nothing but consuming energy, and we really felt that there needs to be a better solution. I have a few slides I can also share. Just take you through that. Um, so just a second here. I think I might need your help for sharing the window or share screen. Okay.
Yeah, you can share the entire screen, Chrome tab, anything
Oh, a
that you
tab.
feel like.
Can I share a window? Is that possible?
Yeah, you
Just
can
one.
share the window. Anything is fine. Anything you share will appear here.
Okay. So I guess I'll have to just go to uh, share screen, right? Is that the thing? Present under present share screen,
Yes, yes.
uh, and then hit one more share screen. Oh yeah, it's perfect. Okay, thank you. That's great. All right, so I think you can see my slides. So there it is.
Yep.
Yeah, uh, so here, essentially, what we're talking about are dramatic amounts that we see in terms of savings, simply because of over provisioning. I mean, this is like this first use case was in the sports betting, and you can see that where they have events, even though it's not unplanned, they know it's coming. They just don't know how much to scale, or actually, literally, they don't know how much to scale up. So then, one of the things is, uh, first of all, you need some knowledge of how many microservices and how much these microservices scale up. So there is a difficulty with that. So even trying to understand that, and then so you just do your best, and over provision drastically. So you can see that with our solution, the savings can be considerably a lot. For that, again, it's not just cost, but it's the carbon footprint. So whenever I say cost, you can translate that to carbon footprint. So because that's they're one and the same in this what we've seen. Um, and then there are others like fintech. You might think, well, why is fintech? They don't. It should be a pretty stable. But usually, what happens is only at deadlines for tax filings that you get these spikes, and then they again go around, making sure everything's over provisioned, because nobody wants your customer experience to be bad. So that's the reason. Retail is another one, like I mentioned before, with the CX. Um, we have also integrated this with Kepler so that you can see for yourself, that where you stand, and what you can achieve with this. And we have seen drastic reductions, even on the Kepler dashboard, even on the order of 50% in some cases. And what is going on underneath? I just want to give you an idea. So I know there's a thing. There are HPA, VPA. These are available, but what happens is that because you have an application with 100 microservices, let's say, and that's not a big amount. That is pretty common. In fact, it's on the low end. I've seen ones with in several hundreds. And now you expect the DevOps guy to go around and setting each of these individually. It's just not practical. So what we've done is that we said, just um, let us take these metrics. We would essentially, it's a SaaS. We take these for each and every pod. We look at the metrics on actually each and microservice. Look at number of pods, the latencies, the any errors that you're seeing. All of this feeds into our AI engine, where we do the analysis and give you back number of pods you have to scale each microservice to. So, and this works in conjunction with VPA, or for example, or if you have Carpenter, it works with that. So it is because the HPA is sort of, if you look at it, it's really at the top of the pyramid, because it's the thing that ultimately is responsible for using resources. And so if you can tackle the problem there correctly, then you get benefit in the rest of the pyramid. So that is the thing. And this is literally what you have inside of that SaaS. So you have a thing which is a pod capacity estimator. What that is it looks at the number of pods. It looks at how much you have to scale for a particular load, and this is able to get a good model, like a digital twin for that microservice. We also have predictors for the traffic, whether it's a combination again of multiple ML models, but it'll tell you. So this, the beauty of that is that you can hide some infrastructure latencies, for example, and then these two come together in the proximal policy optimization, which is the RL engine, which then what it does is it takes this inputs and then it walks through this observation space, and it's able to find a path through that space that will drive you to an optimum position. So it's it's a reinforcement learning, so it works through rewards and negative rewards, and then gets you in the right trajectory through that state space. So, and we are service graph aware, which is very, very important, because if you have challenges at a leaf node, for example, there is no point in you adding resources above it, because you have to apply the resources at the right location, and then you don't need to then waste resources elsewhere. So this is all about being careful with the way you scale, so that you are doing it in a responsible manner. And we basically, there are many advantages to this. One of the most important, of course, is from the human capital, because you're not stressing out your SREs, because they are ultimately responsible for your performance. But then they don't have the right tools, and we wanted to give them some tools so that they can do a better job. But at the same time, when they do that, you get immediately benefits in carbon footprint and in cost. So this is and reinforcement learning is sort of the only way we could do this, because there are too many parameters and variables at play. and there's no better way than that for predictive scaling. Um, that is learning continuously uh, and giving you real-time predictions. So you have lower cost again, as I said. Lower cost means lower footprint, uh, and and we can see dramatic savings. This is for one of the examples that we have shown. You can see it's unbelievable. It's like almost a third of what it was in terms of node minutes. And by the way, it's all for the same SLA. So that's the beauty of it. So that is my brief deck, but I'm happy to discuss any questions that anybody might have, and uh, or either one of you, Sam.
Yeah, and like we already have the HPA and VPA. So how you like frame this? Like how this is using, like for the existing, let's say we have an existing Kubernetes cluster, what all stuff uh, one needs to install to get the benefits of smart scaler, like how one can use it.
Yeah, it's very straightforward. All we need is a agent to be deployed in the cluster that is reading the metrics from Prometheus or some other data source like Datadog, and then these metrics are then sent back to the SaaS, which will then run it through the inference model and send back the uh, the recommendations for scaling up or down. And then we use CADA as our interface to HBA, and then it tells HBA exactly how much to scale up and down. So you don't have to rely only on, let's say, a CPU threshold, which is all that comes out of the box. So this gives you exactly how many pods you have to scale up and down uh, based on data. So it's
So
a very
it's the yeah, so it's the HPA and CADA and the inferencing model that is getting the insight metrics, and then smart scaler is telling after the communication that this is what you have to scale up, scale down
yeah,
intelligently and fast. Okay.
exactly.
Any part of this that is like any part of the solution is open source, or is it all closed source, or what are your plans for that?
Yeah, so CADA is open source, and without CADA,
Yeah.
this is possible to do. And the only thing that is, I mean, the model, of course, is a SaaS, right? So it's run it's in the cloud, and um, we expect that to uh, kind of follow the same trajectory as ChatGPT. So if you think about this, it's like a ops GPT. you know, it's where we are essentially on that path. So we would, as we will get more and more data, we expect that model to grow in complexity and essentially handle a variety of behaviors of pods, and that's how it would. So it's not a thing that you can open source because it's a thing that's available now. We would like to make this available to people to play with, and we are getting it into the marketplace places, I should say, and so that people can play with it, and maybe even have we're working on like tiering of that, so that there's a way to have a free tier, essentially because it does add a lot of public good, so that's something that we're looking into it.
Awesome. Divya, any
I
questions you
have a
have?
question. Yeah, I just had one, Raj. So we were like, again, this is borrowing from what we um did yesterday with Mark and I mean basically Mark from Deep Energy. So I was wondering if there's a plan to incorporate like um metrics beyond the ones that are collected by these, like maybe closer to hardware metrics, like power consumption or something like that, that is closer. I know that, you know, the number of like carbon dioxide consumption or something like that. Do you have like plans to incorporate more number of metrics other than the ones that are being you know, measured so far?
Absolutely. I mean, that's a great question, Divya. I mean, we one of the beauty of going with a AI model, and especially this sort of reinforcement learning model, is you're not really limited in what how many metrics you can have, how many things it needs to optimize for at the same time. It can do it, and so of course there is on the other hand, it might take longer to converge, but so be it. I mean, but once it converges, then it has baked into it all that intelligence. So um, we one of the projects we are looking at is adding temperature and some other environmental factors. So because that also affects the outcome, and then have an integration where we use Kepler as the sort of guiding post to for the model, so that it can, when it finds that optimal trajectory in the state space, it is actually going in that direction of towards an optimum point. So these are things that we are, but there are other reasons also. Like there are reasons where, in some cases, certain types of processors, like GPUs and few others, they have certain operating ranges where they need to operate within, and and then if they are pushed beyond that, their failure rates actually increase. So it's important to stay within some bounds, and then furthermore, if we expand our window into beyond just a cluster, and look at the data center itself, you can think of a situation where you know that the loading of is such that you might need to uh, move this workload, or have a thing where this data center probably is not the right one for a particular kind of workload. And then so we have one more product, which it's called the Global Traffic Director, and that kind of works in conjunction with this one. And the idea being that if there are reasons where you need to direct workloads to a different location, then that the traffic director would actually influence the DNS to direct the request to another data center, and then which would probably, right now it's just looking at these metrics that we have, which is just loading. But I can see a scenario where, like you had pointed out, where I think it was the previous speaker, a guest, where that they could actually direct it to a more ecologically advantageous, from a sustainability point of view, data center, if one of them gets overloaded. And it is a real problem, by the way. I mean, there are situations where data centers essentially shut down, and they cascade into a series of faults, and which is happening now because of the challenges to the cooling systems because of climate change. So there is a need to look at the bigger picture.
Absolutely. Thank you for that, Raj. Sam, do you have any further questions, or do we have any questions on the chat? I can't see any. Do you have any further questions?
No, I think that's good. So we have the smart scaler, like Raj mentioned, and there are possibilities of a free tier where you should be able to in future use it and test it for the purposes. I think it has some good. I was just going through the docs, and it has some good points on the reduction of cost, carbon footprint, SLAs, and it shows its power due to the reinforcement learning in UI, because it tries to understand your current ecosystem, gathers the metrics, and relearns and retrains on your usage of the pods, and then tries to predict it. So I think that's an intelligent way of doing the using the AI ecosystem and then predicting the behavior, plus the open source projects, Kubernetes, HPA, and Keda to complete the whole cycle. So yeah, I think that's pretty cool. I hope the free tier comes soon, Raj. Please keep us posted on that, and we'll add that to the description of the video as well. And yeah, thank you so much for joining in. And I hope everyone got some insights on how Avesha is tackling on sustainability. They, as an organization, are not only considering it but developing solutions for others to leverage as well. So thank you so much, everyone, for tuning in. See you tomorrow, same time, 8:30 a.m. PST on Cube Simplify. Um, Bye.
Bye. Thank you.